0. So this is an IPv4 format, 255.255.255.0. Okay. So, and we're going to play with binary. Remember, we played in binary in week 1 or 2. And the binary notation for the 255 is 8 ones. Okay. So we have 255, 255, 255, 0. That equals to 1. I'm not going to say all these ones and all these zeros. Okay. So let's play with this a little bit more. What I'm going to have you do, you're not going to do it right now. You're just going to watch me. So don't worry about trying to follow along. You're just going to watch. Okay. Everybody clear on that? We're just watching. All right. Okay. So let's start with the table. Let's do a refresher on 1, 2, 3, 4, 5, 6, 7. I think that's 8. All right. All right. So whenever we're counting in binary, we start on the far right side and we start with 1. Does anybody remember what's next? It doubles, if that helps.
1,
2. What's next?
4,
Yep.
8,
Yep.
16,
32,
Yep.
64,
1,
32,
Yep. 128.
120.
120.
Yep. Okay. Thing is, let me get back over here. All right. I'm going to clear out my little notes. Okay. Okay, it says that in this line right here, a 255 in the binary equals all those ones. So let's test that. So what they're saying is if we put a 1 in all of these spots, in these places, I want to do something real quick, just make that prettier. All right. So if we put a 1 in all of these, what is the decimal value? And feel free to get a calculator. And remember, if 1 is turned on, so it would be 1.
Yeah, it's 255.
Yeah, it's 255. Yeah, exactly.
Yeah, equal to 255.
Yep, exactly. So it's 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1.
Equal to?
Yep, equals 255. So that's what they mean when they say the 255 equals all those 8 ones in binary. Make sense so far?
yes,
Yeah.
Okay. All right, good. All right. So let's look at this. Like, let's look at an IP address 190. Oh, Duma.
Yes. Go back to the numbers. If you say, yeah, if you want to put it, replace if you build the diagram, how can you build that one?
I'm sorry, what was that?
If you want to build diagram like this, squares, if you want to put it in squares, how can you put it?
I did a table. So you asked me how I did it?
Yes.
Okay. So what I did was I used this table and I just put it up here. And then there's like little plus symbols. You can add until you get to 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I just typed in the numbers.
Yeah.
Uh.
I got it. Yes. Okay.
Let me go ahead and delete that. Okay. Okay, so in this example here, we got an IP address of 192, 168, 123, 132. So let's just go ahead. I'm going to copy that because I won't remember it. So we got 4 bytes here, right? Each byte represents 8 bits. So I want to make another table. So it's 2, 3, 4, 5, 6, 7, 8. And 128, 64, 32, 16, 8, 4, 2, 1. Just going to make them centered because that's it just annoys me if it's not. And I want to make them colored just because that's how I like it. All right. So we're going to need this 4 times because each one of these tables is going to represent one of these bytes. So I'm going to hit copy paste. Let's see. Move it down. Copy paste. I'm doing the keyboard shortcut. And again, you're just watching me right now. Okay. All right. So 192. What do I need to put in here for terms of zeros and ones to get 192? So we need 128, right? Help me with the rest. Do I need a 1 or a 0 under 64?
Teacher, how we can know that?
Because
One.
these numbers,
Mm-hmm.
okay, remember if it's turned on, it needs to add up to 192. So if these numbers, for example, let's do the first one together. So 128 plus 64, what does that equal?
198, 192.
Yeah, 192, right? So would I put a
Yes.
1 or a 0 in?
Oh, yeah. Uh-huh.
1.
Yes, teacher.
Yep.
1.
Would I put 1 or 0 in here? 30 for under 32.
0.
Yep.
0.
Yep.
0.
0.
Yep.
0.
0.
0. 0.
Good.
0.
So what about 168? Let's put a 1.
1.
We have 1,
Okay.
0.
0,
Mhm.
0.
1.
0.
1.
Oh no, I don't remember. You'll want to trust you on the math.
1. 0.
Okay.
No.
So
No.
0. Okay.
Is no. We can restart at 30. 16 is no 1. Is 0.
Okay. So 128, 32 equals what? 160. Okay. I think I need 0 there or 1 there. Is that right?
No.
1.
It's not right.
Okay. Let's see. So 128.
16 is 0. The 16 is 0.
16 is 0.
0. Yeah, 0.
Okay.
8, 1.
30, 50. Which one do I? 128 plus 32 equals 150. I need to be 168.
Yeah, 8, 1.
Yeah, 16 would be 1, wouldn't it?
Oh.
Let me.
But for me, I find 1, 0, 1, 0, 1, 0, 0, 0, 0.
So 1 0 1 0
1, 0, 1, 0, 1, 1, 0, 0, 0, 0. 0 40.
40.
Yeah.
So it's 50. Yeah, okay, yeah, we're right. Okay, 132. 30. Yes, okay, that's right. Okay, thank you. I did earlier, but I don't remember what the math was. All right. All right. So okay, let's get rid of that. And so that was 192. This is 168 and 123. Feel like I'm Price is Right. Okay.
Yeah. It's 0
Okay, 0.
1
Uh-huh.
1
Uh-huh.
1
Uh-huh.
1
Okay.
0
Uh,
1 1.
So 64, 32, 16, 8. So, and the last one was 132.
Yeah. 1 is 1 0 0 0 0 1 0.
This is
It's 1. It's 1
okay.
0
And then,
0.
yeah, okay. All right. So that's a refresher on the binary. Everybody, does that starting to ring a bell for you guys?
Yes, teacher.
And the hardest part sometimes is just the math. All right. All right. So with that in mind, so we got the 192 going back into this diagram here. We got an IP address of 192, 168, 123, 132. And as we can see, what that gives us is this right here. So let's just go ahead and I'm going to go ahead and type this out so that we can see it. 1 1 0 0 0. It's all zeros. 1 2 3 4 5 6. I think that's right. Okay. And 1 1 0 1 0 1 1 2 3 0 1 1 1 1 0 1 1 and 1 0 0 0 0 1 0 0. So I think I get that right. Okay. So this represents the decimal. Okay. This represents the decimal value. Okay. And this represents the binary value. It's the same thing, it's just represented it in different ways. So 192, 168, 123, 132. Want to do something here just again for distinction purposes, if I can, if it'll let me. Yeah. The colors have no meaning. I'm just making it as a visual just to help with the distinction of it. Okay, and the last one, I'm just going to leave the last one black. Okay. So we can see the representation of how those goes with each other. Going back over here, we have a subnet mask of 255, 255, 255, 255, 0. Okay. So we already said that earlier that 255 equals all ones, right? For the subnet mask, remember? Everybody in
Yeah.
agreement? Okay. All right. So I'm just going to, sake of time, just going to copy this. Let's see. Okay. All right. So it was 255, 255, 255, and last one was 0. Yeah, 0. Okay. So what should this say 255, this last one, or what should it change to? This is, I'm sorry, maybe rephrase that. So this is 0. Do I need to change the values in any of this bottom row?
Yeah.
Okay. What do I need to change them all to?
Oh, 0, right? 0.
Yep. All are 0, not 10. Let's see. Okay. So with that, we see you've got all these ones. I'm not going to say all the ones. And then we got the zeros. Okay. So I'm going to bring that over here. 255, 255, 255, 0. And that translates to 1, 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 2, 3, 4, 5, 6, 7, 8. Dot 0. And I think this is where we might be stopping today. I just want you to get a good grasp on this before we start talking about the cider notation tomorrow. Let's leave that black. Let me look at my other one to see if I was going to have anything else. Because they're going to do what you just saw me do, is what your guys are going to be doing. And again, it's just for practice and retention and just kind of making those pieces connect. All right. And just drawing arrows. All right. Everybody with me so far?
Yes.
Okay. One more thing, and then it's your turn. All right. So basically, the first 24 bits of this number, and this is the example that we're going off of the subnet mask, are identified as a network access. And the way they are identified as a network access is because think of it as a light switch. It's turned on. They're ones. Okay, it's turned on. So it's saying it's like, hey, we're calling that, we're reserving that, and that will make more sense when we talk about CIDRs. We're reserving that, and that's part of our network. We cannot change that. Just like with a zip code, it's not something that you're going to change unless you just completely move. That's not going to change. It's part of our organization, so to speak. So with that being said, trying to make sure I don't get myself confused. That's been, so with that being said, what we're going to do now, okay, we're taking our IP address. That's not what I want to do. There we go. We're taking the IP address. Okay. And since we know that 255 means everything is turned on, like it's all ones. Okay, what we're saying now is that this, and this is reserved as part of the network. So I'm gonna use my little highlighter tool. Okay. This is part of the network. Okay. Whenever we're assigning IP addresses, this has to stay the same. And we know that because everything is turned on as a light switch when we look at it in the binary version. Okay. So 255 means everything is turned on. It means it's used, means like there's circuits going to, however, whatever way makes it stick in your head. Like a light switch, it's turned on, it's used, the energy is going somewhere, it's reserved for the network. All right.